The METUS Tech Show.
Welcome to the METUS Tech Show, a show for HVAC professionals by HVAC professionals.
The METUS Tech Show.
Mitsubishi.
I don't care what you say, Juan. No matter what. I hate it. I don't like it. It's disgusting. I don't care what you put it on.
I don't understand. I love it. It tastes so good. I put it on meats. I put it in salads. I put it on sandwiches. I love mixing it with jelly on
God.
Rye bread, rye toast.
Oh, I'm getting sick.
Oh, that is taste
hold on.
overload.
Just in case you guys don't know what we're talking about blue cheese. Blue cheese is horrible.
It is awesome. How about gorgonzola?
Oh, it's the same thing. It's just worse.
No.
Yes, it is.
Have you ever tasted goat cheese? It's awesome. You need to taste some goat cheese.
Is goat cheese blue cheese?
No.
Okay, then we're not talking about goat cheese here.
Just giving you something.
Let me tell you a story. The wife sees a block of Romano cheese in the refrigerator. She sees a little tiny blue on it, and she throws the whole block out. $9, $10 worth of Romano cheese, and then she'll put blue cheese, and I don't understand. That's mold. It's the same thing. I throw that out, and I get in trouble.
That's right, because she loves blue cheese.
All right. Well, welcome to the METUS Tech Show. What's our topic today, Juan?
Today, we're going to talk about communication breakdown.
What?
Communication breakdown.
I'm sorry, what'd you say?
Yeah, exactly.
Yeah,
the
there you
topic.
go. Communication breakdown, great topic.
So, when we're dealing with the communication breakdown issue on a system, where should we start?
Well, I think anytime we start with a piece of equipment on a startup or a service call, probably the first thing we're looking at L1, L2. Looking for voltage there. Looking for it within our range, 187 to 253 volts. Make sure it's within that range.
All right. And then what is the most important wire in the whole system?
Probably S3. Probably S3 is our communication.
Let's think of it on the supply side. What is the most important? What typically comes with L1 and L2?
Ground, obviously. Ground.
I mean, the system needs a proper ground for it to work properly, right?
Absolutely. And being from the Northeast, way before Mitsubishi gas furnaces, grounds, you lose everything sometimes.
So we've confirmed L1 and L2. We got good voltages between the range. Mm-hmm. What's our next go-to?
I'm definitely going to go right next to it. It all takes a few seconds. S1, S2. Make sure that's somewhere in the same range. Give or take a few volts, then L1, L2. And then we're going to switch our meter over to DC, go S2 to S3. And that's where we're looking for that bouncing voltage along that. And tell us how that works.
Yeah, the signal is 12 to 24. Sometimes it could be 8 on the low side. It could be 30 on the high side. It all depends on our incoming voltage. Now, the way that fluctuation or bouncing voltage works is when you first power up. Typically, what powers the indoor unit? The outdoor unit.
Sure.
Right? So that's where S1 and S2 comes in. So when you first power up the outdoor unit, immediately 24 volts DC is sent from the outdoor unit to the indoor unit through S2 and S3. So once the indoor unit sees that 24 volts DC signal, and everything is okay, it sends the indoor unit, or the indoor board specifically, sends the 12 volts DC signal back to the outdoor unit, telling it, hey, I see you, I'm connected, let's run. Yeah. And so that's that fluctuation, 12 to 24 DC volts that we talk about.
And that actually brought us to a previous podcast where if we had individual switches for the units, as far as power switches, service switches, sequence of operations is important. And you start up the indoor unit first, because then it would be, that signal would come from the outdoor unit, and it wouldn't hear anything. So it'd say, I have a problem here. But that was in the previous podcast, if you all remember. So new installations, that's always a challenge. Even though it's a one-to-one, what we're talking about, it's very easy to cross those wires. Typically we use color-coded wires, but once again, two people doing it, a job together. Somebody's wiring the inside, somebody's wiring the outside. You can easily cross one of those. And that comes in as service calls on new installations.
And that happens a lot when you've got two guys, because companies expect installers to install a one-to-one. in 4 hours.
Yeah, in a short period of time.
So you've got an installer inside, an installer outside. They're not communicating. Typically, that's going to create a communication breakdown because they're going to cross the wires, specifically S2 and S3.
So the other thing that can happen is, while you're pulling your wires or whatever you're doing, not paying attention to it, you could maybe chafe the wire, nick the wire, and you could cause a short. So that wire could be shorted to each other, or S3 could be shorted to ground. So it's another concern you should take care of. In most of the situation, it's typically a short run. You're following, at least, what I'm used to doing is following that control wiring with the pipe. So as I'm running the pipe, I'm doing the same thing. I'm running the wire at the same time.
And also, what we need to understand as technicians, typically, what does DC positive is always looking for?
It's looking for its favorite friend, ground.
Absolutely. So if S3 is shorted to ground, what happens to the signal?
Oh, the signal's lost.
Goes to zero.
You're
So
going to
there's
have
no
a communication breakdown right off the bat.
Exactly. So that's why we always say S3 should always be a solid wire from the outdoor unit to the indoor unit, or we also call it a home run.
Yeah, from beginning to end.
Right. No wire nuts, no solderless connectors, no splices, just a solid wire going from the outdoor unit S3 to the indoor unit S3. That is, and considering that the wire size is very important here too.
Now, just in case you're required or you choose to put in a service switch, we typically look at a 3-pole arcless service switch. So in that case, guess what? You are breaking S3 at that point, but where it's an arcless service switch, you're not going to have a communication problem because of that switch. So that is the exception.
And by the way, Mitsubishi sells those type of switches, and you can find it in MyLink Drive. Mm-hmm. It's
That's what
listed there with a part number.
I believe now everything the way MyLink Drive is set up, I know that back in the old days, you had very little things displayed when you went right to the piece of equipment. Now, you probably have 15, 20 different things, accessories that goes along with that piece of equipment.
Right. So we've covered cross wiring on S2 and S3. We've covered shorted S3 wire. We've covered having a solid wire from the outdoor unit to the indoor unit with no wire nuts, no solderless connectors, and we've confirmed the wire size. What else should we be looking for as far as communication breakdown?
Well, you could look for incoming voltage, whether it's being low or possibly being high. I'm from the Florida area now. I teach down in Orlando, and it is not uncommon at all, to have 248 to 253 volts down there. It's very common.
Right, and then because if the incoming voltage is too low, that's going to create a low DC signal. Therefore, it's not going to create that 12 to 24 volts DC fluctuating signal that we need for the system to communicate properly. So it's going to generate a communication error. The same example is on the high side. Mm-hmm. I'll never forget. I was dealing with a water source heat pump that it had 256 volts coming into the home. Now, how is that possible? Well, I went immediately. The everything inside the circuit boards were chattering. The relays in it were not making because of that high voltage. So I immediately went to the breaker panel and I checked incoming voltage to the house. Sure enough, 256.
And we have no control over that, but
No.
those situations happen all the time.
Absolutely. So we need to be aware of those situations. And the only ones that the homeowner can call is the electrical company. What happened in this one scenario that I'm talking about is one of the transformers had failed.
Yeah.
So it was sending a higher than normal signal.
Yeah, in my whole career, I've always seen brownouts, things being close to a brownout, especially up in the New England area. So those situations are very common at certain times of the year.
Right. And when we're running through a high voltage condition, that really wears those circuit boards out. Mm-hmm. I mean, it can cause them to fail. So what else can we need to be looking for in new installations?
I think you definitely have to look at how, if somebody's adding a condensate pump of some sort, you take a look at how that's wired and how the safety switch on that condensate pump is wired, what it's wired to.
So, I've dealt, unless they have changed recently, but as far as a year ago, I was reading the installation instructions of a third-party condensate pump. And the installation instructions was saying to cut or to break S3. What do you think about that?
I think that's a bad idea.
Absolutely. What does we say to interrupt S1?
Our literature says to cut S1.
Right. So regardless of what the installation instructions on the condensate pump says, we want you to break S1.
And where one's going with that is that if we break S3 through the backup switch on the condensate pump, you could have a communication error on the controller or a flash code. And so now you're looking for a communication error, checking all this stuff, and it's the condensate pump. And it's now it cleared itself up. Let's say the condensate pump drained a little bit, 3 or 4 hours later, especially in Florida, we're going to get a lot of condensation. You're right back there with the same problem. So now you get, you're back on a follow-up on a service call. So, be aware of that. It's in our literature.
Right. Another thing that we tend to take for granted is loose connections.
Right.
We need to make sure that all our connections are tight. We need to be careful how we strip that wire. Not to, to use wire strippers instead of using side cutters, because how many of the strands are cut?
Absolutely, because if there's 22 strands of wire in there, whatever the number is, you cut off. I'll do math better for one here.
Thank you.
One needs math. Let's just say, for instance, 10 strands, and you cut off 3. Wow, what's the big deal? Well, if you break it down into percentages, you just took 30% of the wire out of that circuit.
Yep.
So, and it's the other thing too is like on your wire strippers, I go up to units, and I'll see a 1/2 inch to 5/8 of an inch of wire stripped. And it's just too much exposed because if we talk about existing situations, I'll bring this one up real quick, what I'm talking about now. But right on your strippers is a gauge. I'll admit, it took me a few years to say, what is that measurement on my wire strippers for? And it's for the length of the wire the casing that should be stripped off of that.
Right. So we need to be very careful when we strip wire. Also, when you cut your outside jacket that contains the 3 conductors, you need to be careful, especially when you're using a box cutter or a side cutter, that you don't nick the internal wires, because eventually they can short together, and that will create problems.
Absolutely.
So we pretty much covered everything that we may find on a new installation. So now let's move on to existing installation, Roland.
Okay, so one that's been running for a while with no problems,
Right.
and then something occurs. Okay, all right, let's go for it.
All right, so what is the first thing we want to look at on a communication breakdown in an existing installation?
Well, if I'm looking at something that's been installed for a while, I'm probably going to just start to look at my switches, look at my float switches, see if something's open in that area. So it may not be a problem, it's just something that happened as a warning, such as it's not draining or something along the lines of that. So I'm going to look at whatever float switches I have to make sure that they're closed.
All right. Also, what if we have, again, wrong incoming voltage, because we may have had proper voltage on installation and on startup, but 5 years down the road, things start happening, so the incoming voltage to the home or the residence can change. So we need to check that out. We need to do that voltage check. Always L1 to L2 first, then S1 to S2, and then look for a fluctuation across S2 and S3.
And one of the things I say in my class, because when you open up a Mitsubishi panel, the first board you're going to see, not a bird, because if it was a bird in there, that would be a problem.
You'd have
all right,
feathers
we'll
all
talk
over
about
the place.
No, we'll talk about that in a minute. All right,
you need
rodents
to go to your
are now
truck.
birds.
You need to go to the truck and get a bag of seeds.
But the first board you see is the control board, and on that control board is fuses. It's not always as clear as you want it to be in the service manual, but sometimes it may say check incoming voltage, and kind of in parentheses that's not there. That also means fuses. So, L1 to L2, S2 to S3, change it to DC. S2 to S3. Then back to AC and check your fuses. No more than 3 minutes to do all that work.
Right. So we've checked all the voltage, and the voltage looks fine. So what else should we be looking for?
Well, we're going to look for rodents and reptiles. Now, you can talk about rodents because you're up north, and I'll talk about reptiles down in Florida.
So talk to me about reptiles.
Okay, so when I first moved to Florida, everyone says reptiles, little lizards, geckos, whatever you call them. And I was like, come on, they can't be that big of a problem. Well, they are a big problem, and they get in behind the boards and they touch the two correct places. They're going to short out the board. And as I said earlier about stripping that wire, I don't know how many times I've seen between L1, L2, S1, and S2, a nice little rodent, like a little tiny jumper, burnt on that board perfect. And so they're there all the time. It's a big concern.
Yeah, and then in my neck of the woods, snakes and rats and mice. How in the world do they get inside these units? I mean, because they're not small objects, but they always seem to find themselves in there. And like you said, they always like to lay across high voltage.
Well, it's also warm in there too, buddy.
Yes.
You know, those boards, that's where the warmth is. That's one of the reasons why they're drawn there. But you know, working in my New Hampshire days, all right, we used to have field mice eat everything. I don't know, is that wire casing delicious to them? I guess it is. But it's the last meal they had.
Yes. Also, we need to be aware of weather conditions.
Oh, yeah, big time in
Snow,
Florida.
deep
Yep.
snow. If any of the wire goes under snow, snow turns into what when it melts?
I would say ice.
Ice or water.
That's right.
So it can permeate and create some of those communication breakdowns.
And seeing that most of the towns in Florida are on the coast, saltwater corrosion is rampant.
Right. Now, another thing that we mentioned in the new installation side about not having any splices or anything like that, or using solderless connectors, you know, what if they used them and things worked on startup and they worked for 5 years, but now things are not working properly?
Well, that's actually something I preach in class, too. Is whenever you splice a wire, you know, with a wire nut solderless connector, you're going to have a problem. What I can't answer is when you're going to have that problem. So, yeah, even though it's been running for 5 years, and, you know, that problem could have happened a couple times where the customer knew, just go reset it, whatever, it works fine. And then finally, like, I'm done resetting it, I'm going to make a phone call. So that's something that's a little bit more difficult because if it's up there in the ceiling in the attic space, you may not be able to get to it easily. But yeah, that could be a concern.
Right. I mean, and you gotta be careful with junction boxes and so forth. And I mean, a loose connection is just that. Whether you have a wire nut or a solderless connector, that's a loose connection.
Yeah, and
it eventually going to loosen up and it's going to create problems.
And that's going to go back to your preventive maintenance service calls, too. When you
Yes.
get a preventive maintenance call, I mean, this is one of the things I check, you know, as they all should be checked like that, is just to check the wire connections. You know, are they getting corroded? Are they getting green stuff on them? You know, screws do loosen up over time. And just to reconnect, make sure the power's off. As far as reconnecting those wires, just tighten them up too much. Don't over tighten them. But that's something that should be checked all the time.
Right. And then we also see fuses. So since you mentioned fuses in the installation, what we've got them here too again. So what are we going to look for?
Well, you know, when you're measuring a fuse, there's a couple different ways of doing it. I typically do it with the unit powered up. I'm looking for no potential drop across the fuse. If you are, you know, you choose to ohm them, just make sure you isolate, so shut off the system. That's a little bit more work. Sometimes you got to pull the fuse out, but time, you know, you might add another 2 minutes to the job, and that's it. So just make sure that fuse is good just by checking it with either your ohm meter powered off or your voltmeter powered on.
And the only thing that is left now is that defective control board.
Yeah, things
Now-
don't last forever.
Right. And the one thing that we should always look for across S2 and S3 is fluctuation or bouncing voltage, 12 to 24. So whenever there's a problem, and let's say we only see 24 volts
But
DC,
solid staying there,
a solid 24 volts DC.
you got a problem.
Absolutely. Now, let's say we see 24 volts DC across S2 and S3 on the outer unit. That tells us that we're okay outside because that 24 volts DC signal comes from the outer unit. So we go on the indoor unit, and if we go to S2 and S3 at the indoor unit, and we don't see 24 volts DC, what's our problem?
That's going to its place it loves to go. We talked earlier about it's going to ground.
Right.
It's spliced someplace.
Right, the wire is bad. But if we do see 24 volts DC at S2 and S3 at the indoor unit, but we're not getting that 12 volts DC return, then that only leaves us with a bad indoor control board or loose connection. We can't we can't forego the basics.
Right.
And then we need to look at the connections and all that. So is there anything else we should be looking for in the existing installations?
Yeah, I'm sure there's other things we could talk about, but
That's
top
pretty
of your
much
head,
it.
yeah, we covered it pretty
That's
good. in
pretty
this one.
much it. So again, I hope that these topics are helping our technicians out in the field, and can't wait to do the next episode that's coming up.
All right, we'll see you
Hasta la
next time.
vista.
All right, I'll be
Adios.
back.